Guys, in this video I'm going to discuss about two-way ANOVA. Previous videos we used one-way ANOVA and assumptions and problems also we discussed. In this video we are going to discuss about two-way ANOVA. So what is two-way ANOVA? Two-way ANOVA compares the mean differences between groups that have been split into two independent variables called factors. The primary purpose of two-way ANOVA is to understand if there is an interaction between two independent variables on the dependent variable. For example, you maybe want to determine whether there is an interaction between physical activity level and gender and blood cholesterol concentration. Maybe in one-way ANOVA, before going with one-way ANOVA, we given some examples like how obese or BMI affects the leg strength. Means BMI may be obese, moderate, and average people or normal people, leg strength. But BMI has three levels, but our main understanding the dependent variable is what? Leg strength. But here they are having two, BMI and also gender, how it affects the leg strength. Dependent variable will be 1, but independent variable will be 2. Even the independent variable, even though two variables, it may be having multiple levels. Okay, that is what two-way ANOVA. So from that we can able to understand whether two factors are affecting the two independent variables are affecting the dependent, or one independent variable affecting the one dependent variable. We should be very clear to differentiate whether it's a one-way ANOVA problem or two-way ANOVA problem. Okay. So similar like one way, we have a two-way ANOVA also has some assumptions 1 to 6. Please do remember the assumptions, very important. Your independent variable should be measured at the continuous. Your two independent variables should each consist of two or more categorical groups, and you should have independence of observation needs to be, and it should be normal data should be normally distributed. There should be no significant outliers, and there needs to be homogeneity of variation for each combination of groups. So that are all the basic assumption. Similar like our previous one way, we have a table for F table also. This is for method 1, method 2, different. So just to show that I'm telling. So this is method 2 also there. Here one more term like sums of squares of interaction is there, but in method 2 there is no sums of squares of interaction. But ultimately the two and one is to understand the interaction effect. So I'm directly jumping into the numerical. Example numerical. An engineer is studying methods for improving the ability to detect targets on a radar scope. Two factors he considers to be important. Two factors are important are the amount of background noise or ground culture on the scope and the type of filter placed over the screen. So no, like a ground culture and also types of filter. Again, as I said, these are two factors. It may have multiple levels. So we will see in future. So mainly they want to check how that improves the radar scope, whether ground culture effects or types of filter which we are using is affecting the final output. The response variable intensity level. The intensity level only similar like leg strength. Here intensity level. So they focus on intensity level and they are comparing the two. So these two, how that affects. So in that first one, ground culture, they has a categorical variable with three levels: low level, medium level, high level. And filters also they use two types, type 1 and type 2. They perform the experiment, and based on the experiment they done they given values like values are tabulated here. So it's a two-way ANOVA problem. Why it is two-way ANOVA problem? Two factors are being there. That two factors are independent. What is dependent variable? Here noise level. There is these all the values are noise level. So this first one, ground culture, has a three levels: level 1, 2, 3. Filter has a two types, type 1 and type 2. So table we made in this way. Okay. Even you can make the table another way also. Another way in the sense, type 1, type 2 here, and low, high, low, medium, high. Likewise, you can able to interchange. According to that, your final results F table will vary. Okay. So what are all the things we need to? First, we need to calculate the degrees of freedoms. Two factors: ground culture type and filter type. Response variable is intensity level. Here A is number of levels in factor 1, B is number of levels in factor 2, N is number of replicates in each column, and N, capital N will be A, B, N. So degrees of freedom for first one is totally culture 3. Three types are there, 3 levels, level 1, 2, 3, or lower level, medium level, high level 3. So 3 minus 1 is 2. For filter, we have type 1 and type 2 filters. So B is 2, 2 minus 1 is 1. Interaction effect, you know, in factorial results we saw. Interaction effect means A minus 1 into B minus 1. A minus 1 is 2, B minus 1 is 1, so 2. Degrees of freedom error equal to AB into N minus 1. AB small n, here small n is number of replicates. 4 replicates, 1, 2, 3, 4. Even in type 2 also we done 4. So total replicates are 4. And capital N is ABN. ABN. If we have a ABN, we can calculate the ABN. So N equal to ABN minus 1. So total degrees of freedom for total is capital N minus 1. So 23. So degrees of freedom we calculated. So what is the next step? We need to calculate the similar like method 2 of one-way ANOVA. We need to calculate the row total, column total, grand total. So we calculate the row total here, 721, this total 731, this total 791. Then column total, all these three values 306, this value 314. Similarly 244 for 81 plus 80 plus 83, 92 plus 97 for 95 is 284. All this cumulative total is 2288. Either this row wise data we have now 721, 731, 794. If we sum all these three, should come 2288. Or we done this wise now, this column wise total 306, 314. If we are adding all these 4 plus 4, 8 values, it should come grand total of 2288. So we can able to easily ensure adding this or adding this should come, the grand total is 1. So once we calculate the grand total, how many number of observation we done? So here 4, here also 4, so 3, so totally 24 number. So grand total whole square divided by n. Grand total is 2288 whole square divided by n. Capital N is 24. So we will be getting the correction factor of C. Once we got the correction factor, next step is calculate the SS total. So SS total, sums of squares of all factors response minus correction factor. Here 90 plus 90 square plus 96 square plus 100 square plus 92 square plus 86 square, 84 square, 92 square, 81 square, dot till 95 square plus 83 square whole minus correction factor will give SS total. Once we calculate SS total, easy to calculate SS between. SS between means this between 1 and 2 and 3. Between culture, this is between culture. So this between, in the sense you have 721, 734, 794. These values you have to take. So 721 whole square divided by how many number of observation? Each has 4 observation but 2 types. So 2 into 4. 1, 2, 3, 4, 4. 2 types are there in term, even though 2 columns are there. So total column 1 and 2. So 2 into 4. Similarly 733 whole square divided by 2 into 4. 4 is what? Number of observation in type 1, type 2. But 2 is total. Similar way, doing that correction factor we are substituting here. So we will be getting the SS between culture we got. So once we calculate SS between culture, now what we have to do? SS between filter type. What is SS between filter type means which data we have to do? Maybe we will be having the data here, column data. Okay, so we'll see. See column data. This total, 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 this total. Same thing. 1 by AN. Previously 1 by bn. See, 1 by bn. 1 by b into n. B into n is b into n. What is b? In the first stage it will be given. B is what? Number of levels in factor 2. A is number of levels in factor 1. So if we calculate for that the culture means, we need to consider the filter. Filter means culture. So here 1 by an. A is 3 level 1, 2, 3 into 4 observation and sum of squares. So 306 plus 314, 313, 286 whole square plus all these sums square minus correction factor will give. So we have SS total, SS between culture, SS between filter. So once we have, we can able to calculate the interaction. So what is the interaction? In the sense 1 by n into sum of squares of both factor 2 minus correction factor, sum of squares of interaction effect. In the sense, again one more term we are calculating, summation of all this summation of all. So totally 6 values we have, that sum of squares of both factor. So this value square, this all square, this square, this square, this square, this square pluses will give. So this is, and this one 1 by 4. Why? 4 observation 1 by n into sums of squares of both factor minus correction factor minus culture minus filter. By doing all these things, we can able to get the SS interaction. So we have all the SS value. Interaction we have, culture we have, means factor 1 we have, factor 2 we have, total we have, degrees of freedom we have. So what are all the values needed for the table? We already found. So just to make the table. So error also we calculated, since SS total is there, SS culture is there, filter is there, interaction is there. Error calculation is easy. Sums of squares of culture type, filter type, interaction, error, total, degrees of freedom is there. The ratio between SS to degrees of freedom give us mean square values. Each mean square value calculated. Once we calculate the mean square value, from the mean square of culture type to error will give us the F value, F calculated value. Similarly for this also mean squares of filter type by error will give us F value for filter type, interaction also. Then 2 comma 23, 1 comma 23, 2 comma 23 will give us some F critical value from the table. Then we can able to compare whether significant or not, accept or reject the null hypothesis. Okay, so this is the problem 1. Problem 2 also here, kindly go through. It should follow, it is also following the same principle. So again repeating what are the things you should remember. First problems are given. Again I am telling, if you are making, instead of type 1 type 2 here, if you are making low, medium, high, in the sense, according to that you will be calculating the value, but rows and columns at the F table will be interchanged. That's it. Okay, no need to worry about that. But what are all the data you need to calculate? First calculate all the degrees of freedom for main factor 1, 2, interaction, error term and total. Then row wise total, column wise total, grand total, your interaction total you calculate. Grand total calculate means grand total square divided by observation will give us correction factor. Once we have the correction factor, we can go with the SS total calculation like this. Once we calculate SS total, we can calculate SS between 1 by bn. Again for between we use between 1 by bn for culture type. For this we used opposites, another 2 terms, and again for filter we use 1 by an into the sum square minus correction factor. This summation we use. Then for interaction we need to find the averages, sums, and that squares divided by 1/4. Interaction is there, SS total is there, culture is there, means easily we can able to calculate the error. Then we can able to make the table. I think we saw one way one method, one way two, second method, and two way also method 1, 2 is there. I think with the correction factor only you guys learn, that is more than sufficient for better understanding. So this is what mainly available in your unit 5, because other if you go with the 2/3 means what? Factors with 3 levels, but it's too complicated for you guys. So I think 2/2 is sufficient. and one-way ANOVA and two-way ANOVA is sufficient for you guys. Okay, so please do refer textbook and solve lots of problems by just watching this video. Not going to help more. Solve more problems with this procedure for better understanding. Okay, best wishes. Thank you.